Thermodynamic state variables and equation of state. The equilibrium state of a thermodynamic system may be defined completely by specifying the values of its state variables. A thermodynamic system, however, may not always be in equilibrium. For example, a system made up of a gas expanding freely against vacuum is not in equilibrium, since pressure of the gas may not be uniform throughout when rapid expansion takes place. Similarly, when a mixture of gases undergoes an explosive chemical reaction, it is not in an equilibrium state because temperature and pressure are not uniform throughout. Eventually, however, the system comes to thermal and mechanical equilibrium with its surroundings. Thermodynamic state variables describe the equilibrium states of systems. These state variables may not always be independent of one another. The relationship between state variables is known as an equation of state. For example, the equation of state for an ideal gas is the ideal gas equation PV equals mu RT. State variables themselves may be of two kinds, extensive and intensive. While intensive variables are variables that have nothing to do with the size or dimensions of the system, extensive variables are those which depend on it. To get a sense of the difference between the two, imagine a system which is at equilibrium and divide it midway physically into two parts. Quantities like temperature, pressure, and density remain the same in either part and thus are intensive quantities. However, the internal energy, volume, and mass of the system are half their original value in either part and hence are extensive in nature.